So, the line's held high when it's not transmitting, which again means no current flows. Then you pull it low for 1 bit duration, that's the start bit. Then there are 8 data bits. The least significant bit is transmitted first, and then you have 1 stop bit. And that's it. So that's how the bytes are transmitted. Now I don't know what the minimum or maximum distance is of the inter-byte spacing. If there has to be, 1 bit of nothing, or if you can run the next start bit immediately after the stop bit. I'm not 100% sure on that.
I don't know. Just want to go over the summer as like part of what activities like news to look over in New York for the C portion. I kind of got to the 4 modes on it. But like, yeah, usually the way I did it, I counted the bits. So as soon as you get to that bit, I was expecting that.
Right. Right, you expect to go high. And that's what it kind of I would expect, is that it has to go high.
Wait, the stop is a 0? Isn't it a... No, I guess it makes sense to be a 0. I thought a stream 1 would be stop.
No, yeah, this has a 0 for the stop bit, and then a stream of 1s after that, effectively. So yeah, those are one of the issues that I could hopefully resolve if I ever got my hands on the real standard. So I'll keep trying. Okay, so yeah, here I should mention that serially LSB is sent first, but I'm going to, in the rest of the presentation, present it with MSB on the left, just because that's how I used to read it. Okay, so MIDI protocol. Again, very simple. All commands are in groups of either 2 or 3 bytes. So byte 1 is either called the status byte or a command byte. I think status is more common, but I've used command for the most part here. Very simple. In a command byte, the most significant bit is 1. In all data bytes, the most significant bit is 0. So you immediately know whether something's a command or a data byte, just by looking at that bit. Although they're all fixed length or have eliminators, so it's not completely clear why that's necessary, but it does make it easy. Okay, so then 7 is 1. The next 3 bits determine which command it is. So okay, there are 7 commands roughly. The 4 least significant bits determine the channel. So again, I said you can have 16 channels, so 4 bits. Byte 2 is the first data byte, and then byte 3 is the second data byte, and that depends on whether or not you have that, depends on what command it is. So it's never optional that you send the 3rd data byte, it just depends on which command it is. Okay, so the first and most common and useful command is note on, right? And all that, what that tells you is that a note was played. So the note on tells you what channel it is. The first byte tells you the note value, and that's from 0 to 127. And the second byte tells you the velocity. All right, so let's talk about both of those. I'll talk about the note and the velocity in a second. The companion command to note on is note off. Okay, so this is command 000, and this terminates the note. So pretty much any time you play, there should be a note on command when you press the key and a note off command when you release it. And we'll talk about, or we'll try to see if we can see that. I downloaded the MIDI analyzer, which should be able to read live MIDI streams. So the note off command looks a lot like the note on. It has a data byte that is the note value, and a second data byte that is the velocity. And I'll talk about what velocity is again. There's also an alternative. You don't have to send a note off command. If you send a note on command, but with the velocity equal to 0, that's a key for the same thing as note off. And why they specify the note off command instead of just allowing that, I'm not sure. I assume note off came before that became a common technique. And we'll talk about what more advanced features of the MIDI standard use that feature. Because it immediately doesn't seem useful to have a note on and a note off command.
Yeah, I mean, when we have the note off and the velocity, is that like the release velocity? Is that like we let go, how long it takes for the
Yeah, I'll get to that in a second. So actually, I guess that would be the benefit is if you want to indicate that it was released slowly or something, then a note off command would make more sense because a note on with velocity 0 gives no information about how quickly it was released. So that's a good point. That's probably a good differentiator as far as why you might use one or the other. The question is, what does a given keyboard do? That may be configurable or it may be fixed or who knows.
Maybe it's useful for like non-deleted keyboards.
Yeah, or even other controllers like a breath controller or wind controller, something like that. But yeah, generally I do think of keyboards when I think of MIDI, but really there are all kinds of MIDI controllers. Okay, so a little about MIDI note numbers. As you'd expect, it's basically a mapping between the piano keyboard and a MIDI note number. And so just each key gets a note. So it's pretty simple. You go from 0 to 127. Middle C is 60 decimal. So it actually goes way up. It goes higher than it goes lower, is where they based it. And again, everything is only defined really for equal tempo. You can't, set a MIDI controller to play just tempo. They weren't really interested in doing that. There are techniques, and there are some interesting things I was reading about MIDI tuning. Like there are ways you can control the pitch. We'll talk about a couple of those, like the example of pitch bend. So those are kind of interesting, but again, that's more of a stretch, normal use. Velocity is exactly like you said. It's basically when you push down on the key, you think about having two switch terminals. One that's normally closed, that's in contact with the back side of the key when the key is not pressed, and then one that is normally open that's only contacted when the key is depressed. So velocity is quite literally the amount of, you measure the amount of time it takes for it to go from normally closed to normally open. So a low velocity number means it took a long amount of time to traverse this distance. And a fast one means it was hit quickly. So it's not really, it gives you an idea of how hard the key is pressed, but it's not a direct measure of how hard.
Yeah, it's always like when I have the velocity thing, like I have I guess just a controller with USB and stuff, and I have to like adjust the settings to sort of sensitive, but not very.
Right.
I was confused by the term velocity, so I was thought it meant more like force in terms of, I guess like.
Yeah. Well, yeah, it's a kind of crude approximation. Because, you can't. It would be harder to measure the force.
Yeah.
And we'll actually talk about that. Aftertouch does measure like holding force, but it's only higher end devices that have that. So velocity was kind of a simple way to figure that out. Yeah, and actually a good point about that actually is on, again, talking about electronic drum sets. With those, electronic drum set uses a piezo element to sense when you hit it. So it doesn't have this kind of switch or anything to measure velocity. So what they actually have is that there you are actually measuring, the impact force of how hard it's hit. But what they give you is a way of of mapping that to a velocity. They have what's called velocity curves. So it's kind of a lookup table that says, okay, do I map this hit impulse linearly to a velocity curve, or do I use kind of a logarithmic curve, or do I kind of an anti-log curve? So you can usually specify the velocity curve when it comes to drum machines and stuff. And I guess that's probably what you're probably doing with your keyboard, something similar. Okay, so like I said, the value range is from effectively 1 to 127, and then 0 is the same as no off. Now, we'll talk a little bit about, if we can get the soft sets working, we'll see this. The velocity, you got a huge range from 0 to 127. So the obvious thing they can do with the velocity is affect the volume, right? But the issue now when you've got